I'm going to talk about the half adder. This is a logic circuit that allows us to add binary numbers. Before we jump into the half adder itself, what I want to do is just recap on the binary addition rules. So when you're adding two zeros together, we get a 0. When we're adding a 1 and a 0 together, we get a 1. But when we're adding two 1s together, we get a 1 0 where we need to carry that 1. The half adder allows us to implement those binary addition rules. So what it does is it takes two bits as input and adds those together. It's made up of an AND gate and an XOR gate, and it has, as I said, two bits as input, and then it has two bits as output, the sum of the two bits, and also the value, the bit that we'd like to carry. So let's have a look at just the examples of different inputs into the half adder. So if our two inputs are 0 and a 0, if you put through the XOR gate, so 0, 0 into the XOR gate, well, that's going to be a 0. And similarly, if we put the two inputs of a 0 through an AND gate, the output is also going to be 0. So therefore, when we're adding the two zeros, our output is also, for both the carry and the sum, for the C and the S here, is going to be 0. If one of our inputs is 1 and the other is 0, then if you put that through the exclusive OR gate, the output is going to be 1. But if you put that through the AND gate, that's going to be 0. So this time our sum value is 1, so that's where we're adding the 1 and the 0, that gives us a 1, but we're not carrying anything, carrying a 0, so that's the 0 bit there. Similarly, if we switch the inputs for A and B around, so they're the opposite, we still get, for our sum, we still get 1 and we still carry the 0. Now in the final scenario, we have two 1s as our inputs on both A and B. When that happens, we put that through the XOR gate, the output then is going to be 0. But then when we put the two 1s as input into an AND gate, the output is going to be 1. So we're carrying the 1, and the sum of those two values is 0.